Hello, everyone. Welcome to the Visions webinar. Today we'll ask, how can open source technologies accelerate energy access for people off the grid? We're joined by an excellent panel of speakers today, including Vijay Bhopal of Connected Energy, Martin Yeager of Libra Solar, both of whom are also members of the Open Energy Access Alliance. We're also joined by Dan Friedman of Green Empowerment and HPNet. And we're also joined by Louise of Wind Empowerment, and also he's a researcher at LAAS CNRS in France. So we're really pleased to have you here today. I'd just like to remind you here at the beginning that we're very open to your questions, so please do send in any questions that you might have during the course of the webinar. Do let us know who that question is for so that we can assign those during the Q&A session that we'll do at the end. Before we get started here, I'd like to do a few quick polls just to learn a little bit about our audience here today and to learn a little bit about you. So first of all, just going to launch a quick poll here about what global region you're in today. It's a little early for the Americas, so if you are in the Americas, good on you for joining us this early in the day. There's as well Europe, Africa and the Middle East, South Asia, and Asia. So thanks for letting us know where you guys are today. And we'll be happy to share these results with you in just a second. I'll close the poll. Okay, I think everybody's voted now, so let me go ahead and share those results with you. Okay. Oh, wow, we do have some people in the Americas, so thank you very much for joining us so early in your day. Also in Europe, so good morning to everyone, Africa and the Middle East, and good afternoon, good evening to everybody in South Asia and Asia. So let me just do another very, very quick poll here. Also, to learn a little bit about what role you might be playing in the world of energy access or in development more generally. So are you working for an NGO or nonprofit? Perhaps you're working for a private sector company, government, academia, or other. So I'll give you guys just a couple more seconds to go ahead and vote there. I think everybody has just about voted now. That's wonderful. And thanks everybody. If you're just joining us here, welcome to the Visions webinar on how open source technologies accelerate energy access for people off the grid. Okay, so I'm going to go ahead and share these results with you all. Okay, so okay, great. So quite a few people from NGOs, quite a few people also from the private sector, fewer people from government, and a third of our listeners are from academia and as well other. So welcome everybody. Okay, and one last poll here at the beginning just to understand just a little bit also about what you guys are thinking in terms of open source. So what role do open source technologies for energy access currently play in your organization or your work? Do they play quite a significant, a high role, and this is something that you're using on a daily basis in almost all of your work? Does it play a significant role where open source is applied for some central functions? Maybe it's marginal and you're just getting started with it, and it's only applied for some auxiliary functions. Or lastly, you're very curious about open source, but it's not currently used in your work. And thank you for joining us today, because that allows us then to explain a little bit better why open source might be relevant for your work. Okay, I think almost everybody has voted there. Let me give you guys just a couple more seconds, and welcome to everybody here in the audience today. We have a really good webinar planned for you today with some excellent speakers. Okay, let me go ahead and share these results with you now. Okay. Okay, so about a quarter of you are already very, very active in open source technologies, a significant role for 21% of you. It's a marginal aspect of your work for 34%, and 21% of you are not using it, but perhaps you might after listening to today's webinar and seeing whether or not it's relevant for you. Okay, wonderful. So what I'm going to do now is go ahead and introduce my colleague, Willington Orozco. He is from Visions, and Visions has been working in this area of energy access for 15 years. And actually, open source has been a significant part of some of the work that people in their networks have been using for all these years. So, Wellington, I'd like to turn things over to you.
Thank you, Molly. Thank you. Do you hear me?
I can hear you very well.
Yeah, thank you, all of you. Hello, everybody. Welcome to the webinar. I'm researcher of the Wuppertal Institute and part of the team running the WISIONS initiative. So, and since its start in 2004, the initiative has focused on experiences, knowledge, and abilities of energy practitioners. And for us, this means those people working hand in hand with the local population, designing and implementing energy solutions. So solutions that enable them to imagine and to create better lives. And through Visions, the Wuppertal Institute, we have been able to provide support to local energy practitioners in two main ways. First, by providing financial resources for implementing pilot projects and knowledge exchange and other kind of activities, but also by providing robust conceptual and methodological research competences so that we can co-create with them knowledge about what works, what doesn't, and why. And along these 15 years almost that we have been supporting different projects and activities, several open source concepts has passed through our ways, let's say. And for instance, practitioners in Latin America have been advancing the design and applications of open source, low-cost tubular biodigesters. So, and sharing experiences and knowledge about these types of designs was one of the main motivations for creating what today are the Red BioLab and the Red BioCall, which are two networks of energy practitioners that Visions is supporting. And also within the hydro empowerment network, there are practitioners that have been working in open source designs of pico hydro turbines. They have tried to spread those designs by making information available online and also by organizing special trainings. And we have been supporting some of those dissemination efforts, for example. And another great example is the open source wind turbine designed by Hugh Piggott. His design are the basis for practitioners from around the world in the Wind Empowerment Association. And Vision has been also supporting the consolidation of this association for almost 4 or 5 years. And within the last 5 years, electronic and digital technologies have also developed rapidly within the energy access space, at least from our observations. One interesting example are the efforts of practitioners from the Hydro Empowerment Network aiming at open source concepts for load controllers. I'm very happy that we have Dan Friedman today, who will share with us some of the experience of this network. And another very interesting example in the field of electronics is the cooperative work within Wind Empowerment, aiming at producing open source modular power electronic components. Therefore, it is great that Louise Vijay joined this webinar. He can share many experience from this association with us, as well as his academic perspective on that. So, and those were only some examples out of our own experience. So, but the application of open source to energy access is a very active field. And we are therefore very happy to have also Vijay Bhopal and Martin Jega for this webinar. They are part of the Open Energy Access Alliance and will contribute more examples and insights and thoughts about potentials and challenges of open source for the energy access space. So, as a very simplified summary of what we have been observing along Visions, we can say that open source concepts serve as drivers of innovation. They trigger creativity and collaboration among people around the world. We have even seen entrepreneurships emerging out of open source energy solutions. However, we have also learned that advantages of open source can only be useful when the required knowledge, skills, and tools are available too, and that working on a voluntary basis is not enough. Other resources are also needed. We, through Visions, we have been able to provide some financial resources for some activities, but also political and institutional backing are very important. If the aim is to empower more people to be part and take advantage of the open source movements, and in particular, those who know the challenges of not having access to sustainable energy out of their own experience of life. I would like to close this introduction and to open the floor to our speakers with this quotation: only through a mix of craft, politics, and the support of social movements will open source fully realize its potential to democratize technology. Thank you very much.
Thank you so much, Willington. That's a great quote to launch this webinar on. And with that, I'd like to move to our first speaker. Our first speaker will be Vijay Bhopal, and he's coming to us from Connected Energy. And this will be followed by a presentation of Martin Yeager of Libra Solar. So they'll each do a quick 5 minutes here. And Vijay, I'd like to turn things over to you. Welcome.
Many thanks. Can you hear me clearly?
Yeah, I can hear you well. Thank you.
Great. Thanks a lot to Molly and and for the introduction. So I will be giving an overview, both from a business point of view and from a market point of view. I'm from a private sector company called Connected Energy, and we make information and communications technology for local companies that are working in the energy space, in both solar and biogas. Martin is controlling my slides, so Martin, please, on to the next slide. My main argument that I want to make, not just the energy access market in general, is that the SDG 7 challenge is absolutely massive, and the current approach to it is not the right one. It's not going to achieve the goal. That is beginning to be acknowledged by the funders, those with political clout in this arena. And I was at an event recently that was run by Shell Foundation, and there was an amazing statistic which was given by one of the high ups there, which was that of all the home system providers, of all the investment that has gone into operating solar, 2 of that has gone to just 4 companies. So you can see that there is a massive problem, both in those that number of people are being reached and the number of companies that are being supported. So my question to everyone to think about is how can 10 or 15 companies reach the approximate 1 billion people that still don't have electricity access, and it's even worse with cooking with. And the clear answer is they can't. So what do we do about that? Next slide, please. So the size of the issue is access to the market. And my argument is that those that have the best access to this market, which is very dispersed and diverse, are local companies. And local companies need to grow in numbers. We expect that thousands of companies are needed to fill this energy gap. And it's support both in terms of capacity and technology. I'm showing this graphic that I put on the right-hand side here, which is from an amazing resource in our domain, which is looking at what does India need to reach its goals. And what they're saying is that there's still more than 300 million customers. This is for electricity access. Almost 1 million need to be created And think 862,000 jobs can possibly be created. That's Microsoft, just to put that in perspective. They cannot be created by just a few companies. So, next, Martin. The way that this can be done is only by some logical thinking. And we need to rethink the way that IP, intellectual property, is thought about in the energy access sector. Hence, open source. We also need to think about what the investment norms are. Are we willing to back, as a sector, 4 or 5 huge companies and make them into tech giants? Or do we want to do it a different way? And the final thing is, how do we enable real technology transfer? If you go to the global conferences in our sector, you hear a lot about technology transfer, but talking about technology transfer and actually doing it are two very different things indeed. Next slide, please. So, in order to try and bring open source to the fore and to enable and grow capacity for local practitioners, we came together and formed an alliance of like-minded organizations. We all do different things. So Connected Energy makes ICT products, Libra Solar works on the hardware, Creative Energy has open source biogas designs, and we're looking for more members. And really what we're doing is building a platform of interested parties in the open source energy space, so that we can support each other and so that we can bring our products to the fore and make them more widely known, and also disseminate knowledge as well. So we do actually have an academic partner, which is the University of Edinburgh, who are looking to open up a lot of their data sets that they've been collecting in this space as well. So on that introductory note, I'll pass over to Martin.
Okay. Yes. Yeah, I'm from Libra Solar, and as Vijay already mentioned, Libra Solar is trying to develop the hardware components of an off-grid renewable energy systems, all as open source hardware. So that means we're developing charge controllers for solar home systems or other energy systems in general, battery management systems, and flexible communication modules. Yeah. So why do we think that open source is so important for technical products? If we look at goods from other sectors like clothes or food, there are already certain standards established in order to consider a product as ethically sound. T-shirts and coffee, for example, should be fair trade to make sure that the producers are paid well. And if you buy organic food or other eco products, you hope to harm the environment as little as possible. But for technology, there is a third very important aspect for a good product, which is openness. We think that this is necessary, especially for technology serving basic needs like electricity. And that's why we think it's so important for the energy access sector. So a product for essential technologies should be open in 2 ways. One is it should be protected. It should not be protected by IP rights, which restrict spreading of the technologies. So ideally, all the design files should be openly accessible and allowing knowledge transfer and participation in all parts of the world. And the second aspect is it should be open in the physical sense, meaning literally it should be easy to open and repair a product. So yeah, and of course it should have a robust and solid design in the first place. And in this way, it will help to avoid generating more and more electronics waste as well. Yeah, and a fully open design is the only kind of design that allows fully distributed manufacturing in the places where they are actually needed. And this brings together all 3 aspects because it allows more fairness because of more local value addition, and it has less ecological footprint because of less energy needed for transportation. Let me give you one example of an open source product and the development process behind it. So what you can see on the left here is an open source IoT enabled solar charge controller, which is integrated in pay-as-you-go systems developed by Connected Energy. And yeah, when you start to develop an open source product, the first and maybe one of the most important points is to choose a proper license. In our case, we chose the Creative Commons Attribution Share Alike license, which is the same as Wikipedia uses as well. So this means that you can more or less do everything with the designs. And it's important to mention that we explicitly allow to use the design also for commercial products, because otherwise it would not be possible to enable local businesses to use the technologies and further develop it. Yeah, then you need an exchange platform to talk to users and other developers. We are choosing GitHub, which is the most common platform currently used for open source software projects. And yeah, increasingly also hardware projects are using this platform. And it's very great to share your design files and also get in contact with other developers. Yeah, an open source design doesn't make sense if the tools needed for development are proprietary and expensive. That's why we chose the great open source tool KiCad for all our electronics design. So you only need a Linux computer and KiCad to be able to co-develop the software and the hardware files of the electronics devices. Yes, and our long-term goal is to grow a community around the open source energy hardware. This is working quite well already for the exchange between experts on GitHub. Yeah, and as we are now starting with the first products in the market, we also want to establish an exchange platform for users. And so we started a forum recently where users in the future can exchange their experiences and yeah, start developing together. That's already from everything from our side, and we are happy to get your questions later.
Thanks so much, Vijay and Martin. Thank you for giving us this kind of introduction to these technologies. So now I'm going to bring online Dan Friedman. Hi, Dan. Are you there?
Yeah, hi.
Hi. Okay. So Dan's coming to us from. Yeah, I hear you well. He's coming to us from Green Empowerment and also HPNet. And HPNet is one of Vision's networks, and they're working especially on hydro empowerment. So Dan, please, I'm happy for you to begin your presentation.
Okay, thanks, Molly. Yeah, so I'm coming at you from a very microhydro point of view. For those people who maybe don't know about microhydro, it's a small-scale hydroelectric power generation technology, which can be deployed in an off-grid setting and generate somewhere between 5 and maybe 100 kilowatts of energy, which is good for maybe 10 to a few hundred households, for depending on which size of system you've implemented. So that's MHP. Another acronym I'm going to use quite a lot is ELCs, which is load controller. And this is a piece of equipment which is used to regulate the energy supply which is generated by a microhydro system. And that just makes sure that the power generation equipment is protected and consumers and their appliances are protected. So that's just a little bit of terminology for people who are maybe not familiar. HPNet, it's a network of practitioners, contractors, organizations, suppliers from mostly the Asia region, although there are also researchers and consultants from other parts of the world all interested in the microhydro sector. And yes, it's quite a diverse network, and I think that's one of the great things about it, because it means that you've got lots of different points of view and lots of different experience from different areas of the sector. And even within HPNet, we have differences of opinion about whether or not open source is actually a good idea. I mean, I would put myself definitely in the yes, it's a good idea camp, and I just wanted to say a few reasons why, really. Specifically for MHP technology, I mean, there are lots of designs that have been released and lots of experiences that have been published. I mean, I've picked a few out there on my slides. The cross-flow turbine is quite a famous one. It's used in a lot of different places, and it's been adapted and adopted by many practitioners. Remote Hydrolyte in Afghanistan, they have their own designs, which they publish on their website and allow people to freely use. And a couple of other ones that I've mentioned there, like the concrete turbine casing design and the Hummingbird ELC, which is nearly 20 years old now and has been used very useful for a lot of practitioners. But how I wanted to wrap that up was to say that MHP technology in general is, in my opinion, a really good example of how open source has brought a very useful technology and helped to improve energy access for a lot of people already. I mean, I'm probably quite new to the sector relative to a lot of people in HPNet who have been doing this for many, many years, practitioners with huge amounts of experience. And it's possible to be a newcomer and get into a field and do some research, like look online, read about the publications that people have produced, and look at their designs and speak to people and get help on it. And really, you can find out everything that you need to know about developing MHP systems. And that's thanks to like hundreds of people and organizations who have spent years developing this technology. So I think like the whole thing is really like a massive open source triumph. Yeah, which is really nice to be a part of. Yeah, okay, so moving on. HPNet's currently working on a couple of specific projects with open source nature. I'm going to apply it to like an educational situation where we're coming up with a set of tools which will be used by practitioners in communities to help to educate them about how they can best optimize the use of their power system. So like with any electrical system, you might have peak and an off-peak time. It's good to make sure that during the off-peak time, that if the power is being generated anyway, as in most situations with a microhydro it is, then you may as well make use of that power. And by using that excess power for like a productive use, like maybe you can generate revenue for the community, or you can, and then you can have that money feeding back into a maintenance fund for the system. And then once you do that, you've ensured sustainability for the system because people can afford to pay for replacement parts or maintain it as they need to. So yeah, that's a set of tools that will be used by different practitioners, and they'll be free to take that curriculum and those tools and to modify them how they need to, and to use them as they see fit in their specific situation. A more sort of direct technology version of the open source project that we're working on is the load controller design. This has been something that's been spoken about in HPNet for quite a few years now, and it's mostly come from the community-based practitioners who sort of get a little bit fed up with having to pay quite large amounts of money for this technology from companies that are often very, very far away or in different countries. And as that's the case, then, you know, like the cost of these things are high, and then you have shipping charges and import taxes and all of these things. So when you purchase the thing in the first place, that's a problem from the start. But then if the thing breaks, then you've got like all of those problems all over again. And so really, people want to be able to produce these things locally and manufacture them locally and maintain them locally. And that's really why open source is a great thing for these organizations. So a few practitioners within HPNet have been working on this, I was involved in one of these sort of streams of the project, and that was supported by Engineers Without Borders UK, CBAT in the Philippines, Sonibong in Malaysia, and now Green Empowerment and WISIONS. And sort of the outcome of this is that we've got a design now that's been deployed in the Philippines in 4 different sites, and it seems to be operating well. And what we're going to do next is to take that design and present it to other practitioners within HPNet. And at the same time, we're going to invite them to bring their designs as well, or the work that they've been doing to try and get to this goal of having this open source design that people can produce. And this exchange will be able to sort of compare and contrast and really get to work on some collaborative development. But also, hopefully, people who attend it will be able to leave, and if they didn't have a design that they could build already, then they'll have one. They'll be able to build this equipment for themselves. I'm just going to skip over these challenges and benefits because I think I'm probably getting close to the end of my time. But the next steps will, for us, will be to see how people get on at this exchange and see whether or not the material goes across well, if there are things that need explaining more carefully or presented in a different way. We can get feedback about how to do that, because we're going to be backing up this technology with build manuals and online documentation and tutorials for techniques that they might need. And so if we can get information about that, then we can produce the right resources that the practitioners need to be able to be effective in this technology. And really, I think this is a great time to be doing it, because with the internet and the connected nature of the world that we've got today, it's become much easier to have this collaborative approach to technology, and I think that's a very good thing. So that's more or less my part, I think.
Thank you so much, Dan. We really appreciate that, and I think it's a really useful contribution to give people a little bit of an idea of how this applies to a specific technology like microhydro power. So wonderful. So we will go over now to Louise Villa. Hi, Louise. Are you there on the line?
Yeah, sure. Can you hear me?
Yeah, I can hear you well. So I'm just going to send you through the request to share your screen, and that should come through.
Can you guys see the presentation?
Perfect. Yeah, that's perfect. Thanks, Louise. So please go right ahead.
All right. So hello, everybody. I'm going to give my presentation is going to be a little bit more on the theory of how open source technology impacts the development or energy access in general. So I'll give you a little bit, I'll present myself in a second, but as an academic, we tend to always love theory over practice. This is not going to be a action theory presentation, but more like, let's take a step back, look at what all these wonderful presenters have talked to us from a more theoretical perspective, and I will illustrate this theory from what is going on in wind empowerment at this moment. Now, if very quick slide about me, I'm a young professor in electrical engineering at the University of Toulouse. I research in energy access, in off-grid systems, in modular power electronics, and bottom-up open source technology at the Louise laboratory. So that makes me extremely grateful to have this opportunity to talk to you guys, because it's exactly what I've been doing for the past few years. And I'm an active board member of Wind Empowerment Network, which allows me to also have a privileged access to the field. So I don't sit in an ivory tower in academia trying to figure out what the world needs. I'm actually in the field with the people who do. Now, basically, what we've been saying so far is that there's about 1 billion people in the world who do not have access to electricity. These people are dispersed throughout the globe, so that means that they have a very diversity of energy sources. We talk about hydro, and wind empowerment we use wind. We can also use solar in some places, and they also have a diversity of cultural uses. That means that from an electrical engineering or energy perspective, there is almost no visibility as to the evolution of their load curve. We do not know how they use the energy. We might guess how they will use that energy, but that means that we're in a situation where we do not know how that will evolve over time. So let's take a look at energy access. A little blink on my slides here. Energy access starts very small with just a few houses. So let's say 1, 2, or 3 houses start installing solar home systems. That grows, they talk to the neighbors, the thing expands, and eventually these houses should interconnect. After they interconnect, they should eventually connect with the houses that do not produce their own electricity, and eventually the whole thing interconnects to the major grid. That's the theory of energy access. And this is actually, there are some papers on it called swarm electrification. And basically, if you look on the left axis, you see the level of energy provision, and you have the tiered approach, where as you go up in tiers, you go up in power. And if you go up in power, from physics, you either go up in voltage or current, or you go up in terms of the speed of your machine or torque. That means that your system grows bigger, more complex. And it's very hard to interconnect things as they become more complex. So there is this idea that there is a complexity barrier to the interconnection of systems, and if we want to have a progression in the interconnection, we need to be ready for that complexity. It needs to be thought into the concept of your system. So what happens in practice? In practice, the solutions that we design or that have been designed by the by market actors, they are tier specific. The answer to a certain load profile and a certain set of specifications that correspond to a certain tier, that means a certain power, that means a certain voltage, a certain current, or a certain torque, a certain speed. They are often incompatible between themselves because they are, if you want to connect something that was designed for a lower tier, the batteries are not necessarily the same technology as for a higher tier, the voltages are not the same, and it's hard to connect things together. And that actually, in practice, generates what we call industrial dependence. Just look at some of these slides on the left. You can see the share, the market share of photovoltaic cells in the world since the 1995. And what we see, the red line here is obviously the red state of the world, China, and it grows and grows and grows, and they are becoming a major player, and obviously monopoly on the production of photovoltaic cells. That means that the price that we don't pay today, we might pay tomorrow if China decides to change the prices of photovoltaic cells like they did a few years ago with new dynamite. On the upper, but China is not the only one that does this. Germany is obviously on the thing as well. If you look in the upper right-hand corner, you see that Siemens installed most all of the big wind turbines. And we're talking about big ones in here. Just to give you an example of how one single industry ends up becoming almost a monopoly. On the lower right-hand side, this is more interesting for us. You see the share of production of inverters in the world, and the blue represents all of the manufacturers in the world, and the green represents the top 3, something like that. So this shows that in the end, maintenance becomes replacement. You can no longer maintain things like we said just before. Here you have a few photos of a blown-up inverter that we opened up, and basically you have a few burn components, but you can't repair them. You have to send them back to the factory. Local practitioners just become retailers because they're now selling stuff that they don't understand. This gets ready for them, and in the end, technology access actually becomes an obstacle to energy access. You see on the left-hand side, a lot of individual houses, each one of their own little water heating system that cannot be interconnected. And all of these houses could benefit from a much cheaper single system. But that's not what happens. Now, on the right-hand side, the obvious thing is cell phones, and they are not compatible with themselves. It's a mess to keep up track of them, and you have to buy new ones all the time anyway. But the question here is, how can energy access be affordable? How can energy be affordable and sustainable? So the point is, and we'll be talking about this, what is affordable and sustainable? Here comes a little equation. Now, don't get itchy. It's just a division. It's what we call the levelized cost of energy. This is a measure of how much, what would be the tariff, the break tariff. That means if you sell your energy at so many euros per kilowatt hour, or your currency per kilowatt hour, you break even. You don't make much money. So basically what this means, you add up all the costs throughout the lifetime of installation, you divide by all the energy it has produced, and it gets you a number. Now, if we look at this, affordable and sustainable means we want to minimize cost and maximize energy production, basically, which means we want to have the least levelized cost of energy. But what does that really mean? That means if we break up this, we have capital investments, operation investments, maintenance, capital costs, operational costs, maintenance costs. We want these to be as little as possible throughout the whole lifetime of a certain installation, of a certain microgrid, for instance. And we want to maximize energy production throughout the whole lifetime of the same installation. So we have to really think in terms of long-term here. Let me show you, for those of you who don't like math, a visual actually of what this would mean. Here you have a graph, red and blue. Blue is the energy production, energy produced, and red is cost. Cost being maintenance cost, operational cost, or capital cost. And the black line is the levelized cost of energy. What this graph shows us, this is a theoretical graph. It's not a real data graph. But what it shows us is that over the years, what happens in energy access, which I showed before, is that we have an expansion. An expansion means we invest a little bit more money, and we make the system more complex. So we have more capital costs, more operational costs, and more maintenance costs, but we go harness more energy because the system grew larger, power is greater. So the trick here is that we harness much more energy than we raise capital. So the levelized cost of energy actually goes down over time. And that's what would be affordable and sustainable. That means that you interconnect things and your price of energy goes down. Your cost of energy goes down. So whoever's selling that energy, a local practitioner, for instance, can get a greater margin. But how can energy access be provided with the lowest long-term cost and the highest long-term energy production? That's what we have to aim for. This is a long-term race. It's not like selling something for the next few years. You have to think about the system as 2 decades, and you have to think about the system that expands over the decades. So we go back to that little equation that might sound a little bit complicated, but what is it to become sustainable? Basically, to become sustainable means you have to find a way to minimize capital investments, capital costs, minimize operational costs, minimize maintenance costs. So we have to lower these costs. And at the same time, we have to try to rise the energy. So rising energy is not truly the issue we can talk about today, because it depends only on going harvest more energy with more technology. I'm going to talk a little bit about it later on. But capital operation maintenance costs, it's what we should be aiming to minimize. And the point here is how can open source licensing lower these long-term costs? How can using open source licensing answer to that question? So let's look at this for a minute. Open source has the potential of basically unlocking all of your supply chain, from installation through maintenance, development, education, operation, and planning. If you use open source licensing, you can create tools that allow you to do any of these actions. There is another one which I didn't put here, which is manufacturing. But the idea here is that by having access to the knowledge, you can operate in any of these conditions. What does it mean in practice? It means that you have this practitioner who is doing education, who has a business model which is educating people, trying to help making some measurements, trying to help people plan their energy investment. And suddenly this person realizes, well, why can't I just do the installation, the maintenance, and the development as well? But the point here is also interesting, is that sometimes technology is disrupted by the arbitrarities of markets. Say, let's get a far-fetched example. Let's say that some big country starts a trade war with another big country. And through this trade war, you have a scarcity of resources, of components. If you have a hand on the technology, you can either change a little bit your design, either make a generic design so you can change the components, or you can go back to educating, operating, and planning and stave off the disruption of somebody else's big ego show-off. So that capability of shifting the business models is one of the main powers of, in the social, from a social perspective, of open source technology. You can either work on the technical or on the social side and go back to it, or do both of them simultaneously, and it works quite well because you have access to the technology, the information, and you don't have to pay anybody to get that information. And what is even better, if it's open source and there is a community of people using it, this community can also help you. It's quite unlikely that you have a global trade disruption. Some people in other places who are not affected as bad as you by maybe say imports or exports issues between your country and somebody else's country because some politician woke up saying that they need to win an election. Still, you can lean on this international network to help you out. So,
hi, Louise. You have about 30 seconds. Can we wrap up in that time?
Sure. Perfect. I'm wrapping up. So if we look at the biggest survival example, which was presented just before, is a technology that is used throughout the world for different people. It's open, and people can actually use it and improve it. But that's not enough. In wind empowerment, what we've been doing is that we've been complementing, because that's just one part of the whole spectrum of what we can do with open source. We've been building market assessment methods so people can plan ahead and decide which countries are the best countries to invest. Or if the people locally can decide if their community is best suited for wind or for hybrids. So we are building a maintenance manual. We built, a maintenance manual that allows us to train people and help them keep up the maintenance. We've made delivery models manual that allows people to understand what is the best type of delivery model that is best suited for their community. We've also been doing a lot of electronics for the past 3 or 4 years. We have a modular data log, which is open source and can be adapted to other types of energy systems. We have a multifunction power converter that's bidirectional, DC to DC or DC to AC, can be used as an inverter, can be used as an active rectifier, can be used as a speed variator. It's been in close development right now. We have a multifunction, on the right is actually a charge controller, which now we've just designed it to have some data logging capabilities as well. We've been doing projects with the European Union, testing the data loggers as you see in the left, or testing the power converters as you see on the right. And to wrap it up, the conclusion is that open source technology, open source licensing is a very interesting potential. Knowing where to host your knowledge database is the key element to be considered. I need to stress this, even though I ran out of time. The state is a historical actor that must participate in the project. Rural electrification cannot be done alone by funding from big corporations that want to do greenwashing. We need to do this as a political agenda. And the universities could be the neutral power broker in this process, because all the technology I've just mentioned, they are being used by other PhD students to run other projects. So there is a need in the academia for the technology that can be developed for testing other more advanced stuff. And in the meantime, we can use it in the field. That's what I've been trying to work for the past 5 years. All right. Thank you very much.
Thank you, Louise. Thank you. So thanks everyone in the audience also for listening. I'd like to remind you to please send through your questions. We'd be very happy to answer any questions that you might have. And remember that no question is too basic. So for those of you who are new to this topic, don't be afraid to send in a question and let us know, what questions do you have about how this could actually apply to your work. that's something that we would very much like to help you answer. So next up, I would just like to do a couple of very, very quick polls here. I'm just going to pop these up here on the screen for you. So let me launch the first one, and then we'll move into the Q&A. So be thinking of your questions and also reply to the poll here if you don't mind. So do you think that open source technologies are essential to addressing energy access and SDG 7 based on what you've heard in the previous presentations of the benefits? And I know we didn't get to hear all of the challenges from Dan, but maybe we can bring up some of those in the Q&A. So just give you a few more seconds here to participate in the poll. Do you think that they're essential to addressing energy access, SDG 7, or perhaps not? Perhaps in your particular situation, they aren't as applicable, or you still need more information and you're not quite sure whether that applies in your situation or not. Okay, I think most people have voted, so let me go ahead and share those poll results with you. Let me share that. Okay. Oh, wow. Okay. So we have 79% of our audience saying that, yes, they do think that open source technologies are essential to addressing energy access and achieving SDG 7. And 5% of you say, no, not so much in your situation, which is fine. It's not going to be applicable maybe to every single situation. And 16% of you still need more information. So hopefully you guys are thinking of some questions and sharing those with us, and let us know. We're also happy to put you in touch with the speakers following the webinar if you need to follow up for further information. We'd be happy to put you guys in touch. Let me share one more quick poll with you here. This is the last one. So since you guys think that open source technologies are quite applicable to energy access and to achieving SDG 7, in which ways do you think they're the most important? And you're able to select more than one choice if you like. So the options that we thought of course, that this is not all the possible options, but we can only give 5 in our poll. So we said collaboration, empowering communities, lowering the cost of energy, increasing business competition, and other, to encompass everything else. And if you have questions about everything that falls into other, please do send those in to us, and we'll come to some of these in the Q&A session in just a moment. Also, while you guys are still voting, I did want to mention as well something that that Vijay and Martin brought to our attention last week, which is a foundation that's called the Energy Access Foundation, or sorry, it's in Access. And let me just pop the website address down here, because we were in touch. My colleague Willington was in touch with Rahul Barua, who is working quite closely on this. And if you guys are interested in funding, as far as I understand, they do have funding available, especially for concept projects and pilot projects that unite open source approaches and energy access innovation. So if you're interested in that, we did want to share that with you and just make you aware that that exists, and maybe have a look at the website. So let me go ahead and share this poll with you. Okay, great. So we have 80% who say collaboration is very important, 75% about empowering communities. Half of you think that also it's important for lowering the cost of energy, and a third of you say increasing business competition is an important benefit for open source technologies. Okay, so let me go ahead and move directly, I think, into our Q&A session here. So let me begin by returning to Vijay with our first question. Hi, Vijay, are you there on the line?
I'm here.
Yeah, so one question I want to ask you, I mean, especially coming from the private sector, I think I'd really be interested to hear your views and Martin's views on this question. Can you really build an energy access business based on open source technology and open source approaches? Is this really good for business? I think that's probably also on the mind of a lot of our private sector folks in the audience.
Yeah, I mean, it's a question with with many answers really, but I can give you my perspective. My perspective is that I've worked and been interested in social enterprise for 15 years since I was a teenager. And if you believe that social enterprise is a good model of business, it can be a profitable model of business, it just means that you have to reinvest your profits back into the company itself, then I think open source fits quite beautifully with that. There is a trade-off, which is that you cannot really base your business on IP protection, intellectual property protection, certainly in the form of patents. So that means that you may find it more difficult to raise money in the form of equity finance through the traditional channels. For some people, that might be a problem, and for others, that might not be a problem. But there's more to intellectual property. There's more to build than just intellectual property. You can still build brands with an open source approach, and of course, you can get a share of your market with an open source approach still. You just have to look at the likes of Arduino and many other tech companies for examples of that. So I think the business still you have to go out, you have to sell, and we all know here that the market is absolutely huge. So I think there are still opportunities with an open source approach.
Thanks, Vijay. Thanks, Vijay. So going over to Martin now. Hi, Martin. Are you there on the line?
Yes.
So I'd like to ask a related question. This one has just come in from the audience, so I want to make sure that I mix in a few audience questions with ones that I also have on my mind. One question is about business models. So we have a question from a member of the audience named Rebecca, who'd like to know about an example of a business model for developers who will use open source technology to bring energy access. Could you give us an example of perhaps your own business model or others that you're aware of that have been successful in this area?
Yeah, for example, if we are talking about this specific topic, I think it would be a possibility to sell the same product in a market in developing countries and also in Europe or other countries for different purposes. For example, a charge controller could be used in a caravan or in camping equipment and then sold at a higher price, and then co-financing the development cost for the other charge controllers sold to developing countries. That could be one example. And in general, the business models for open source projects are already working for open source software. For example, there are companies offering premium features for their products when you pay for them. And for open source hardware, if you really want to release a product to the market, you also need to sell the hardware, or people need to buy the hardware. They cannot just download it. So this is also an opportunity to get some cash flow.
Thank you for that. So moving on to our next question for Dan. Hi, Dan. Are you there?
Hi, yeah, I'm here.
Hi. So we have a question here, actually from the audience as well. What they would like to know is about the training that you were mentioning, and perhaps other trainings that you might be aware of. Where can we get the training in theory, manufacturing, and testing, in particular for microturbines? Are there things that you're aware of that would be helpful perhaps to our audience interested in learning more about this?
For turbines specifically, I don't know any specific locations, although I do know a few good resources online where you can find out about these things. So Energypedia is one really good site where people put publications on there. So they have a lot of information about MHP projects, and they do have information on turbine design. And there are books. There's the Adam Harvey book, which has got information about turbine design. There's a website called pumpsasturbines.co.uk. That's there are. I mean, just googling things really is probably the best advice I can give. Like, because there really are a lot of resources out there, and you just have to do a little bit of digging, and you can find them. But yeah, going on the websites of our partners as well. So the HPNet website has got links to good resources and good libraries, and green empowerment as well. Yeah, a lot of this information is out there if you go and look. And as for in-person trainings, this is something we're trying to do more of, but it's obviously it's more of a costly thing to do, and that's why the internet is so great for this technology at the moment, because it's almost a free platform to have access to this stuff, and you can watch a video on how to do something, or you can read an explanation about how to do something for free, and you know, that can be enough to learn it, which I think is really great for us at the moment.
Yeah, that's amazing. And I did want to follow up with a question that I had as well, for you, because I know we've talked a lot about the positive sides of open source, but to be fair, everything has its downsides. And I know you've worked quite a lot with open source, so you must know some of the major challenges. What have been a couple of the major challenges, and how have you overcome them?
I would say that most of the challenges come from probably three areas, I would think. Open source can be very difficult to get started on, from two different points of view. First of all, as somebody developing a technology that they want to as an open source project, you know, it's generally something that isn't already available or needs to be a combination of things that are already available, and so you've got quite a steep learning curve there to actually go and produce something like that. So there's a big learning experience from that point of view, but then there's also a big learning experience from the people who want to adopt that technology. So if you design something, then you'll know it inside out. But if you then have to go and pick up somebody else's design, and reproducing it is one level of complexity for a start, which isn't necessarily easy for everyone. And if you want to then be involved in changing that piece of technology or improving on it or adding new features, then that's another level of complexity. So I would say that open source is really kind of a trade-off between, like, okay, you don't, maybe you can produce something for a little bit cheaper. That's one of the big benefits of it, because you're producing it yourself. You're not paying for overheads of a company to develop it for you. But then you do have this extra sort of burden of having to get yourself up to speed on quite a few different topics, and this can seem like quite a big mountain to climb. So an important thing to do when you're presenting open source technology, I think, is to try and break this big mountain that people have got to climb to get up to speed with it down into sort of more manageable chunks, and try and really translate the concepts, which aren't trivial in a lot of cases, to make them more accessible to people.
Thank you.
I would say that's one of the biggest challenges.
Yeah. Thank you, Dan. Okay. So next up, Louise. Hi, are you there on the line? Hi, Louise. Are you there? We might have a little technical difficulty there.
Hello.
Hey, is that
Hello.
Louise? Yeah. Hello.
Yeah,
Hi.
that's me.
Oh, wonderful. So let me just ask you a follow-up question here, and this is coming from Willington, actually. So some level of technical knowledge, skills, and equipment are needed to take advantage of open source, as we're hearing from Dan just now, actually. However, this knowledge and these skills are likely difficult to find in places where the energy access challenge is most pressing. What strategies or alternatives do you or the Wind Empowerment Network use to cope with that?
I think the Wind Empowerment Network does not. Let me talk about, try to answer your question first, and if we look around the way our industrialized or post-industrialized society works, it doesn't matter if it's open source or not. If you're trying to understand the technology, you need the tools and you need the knowledge to understand it. Even if you work for a private company that locks down everything, this company is going to have software with licenses and so on, and you have to be able to understand all that technology to use it. So when you look at the way we do things in our societies that are already electrified, basically we send people to university, they get a degree, they go through internships and stuff like that, and eventually they get to the point where they can try to provide their own solutions to whatever market that is around them. So people in the energy access communities are not really different from that, if you think of it in that perspective. I'm not talking about the farmer who is currently, struggling without electricity. I'm talking about their grandson, or I'm talking about the people who live in the nearby town and know a little bit the area and do a degree on a small university, and they end up in the situation where they have their minds full of ideas, with their hands empty, because the knowledge, the things that they use to learn in university are all proprietary. They're all donated by some big company to try to lock them into some sort of technological loophole. So for me, the thing is, we need to train people with open source technology. We need to bypass industry that tries to lock people in. It's great. They're doing their job. They're trying to earn money. That's okay. But the universities have to beef up their open source approach, and they need to use open source technology with communities that exist, so that when you leave your training years, it doesn't have to be a very long-term 5-year course. It can be a 3-year course. But when you leave it, you have to have access. You have to be able to actually make a business out of it. Provide energy to those who need, maybe, or create your own solution. And you cannot do that from scratch. You're gonna end up in a desk job somewhere, or using technology that's already proprietary anyway. So for me, the point here is open source is not something that solves rural electrification issues. Open source is a whole paradigm of development that needs to be appropriated channeled into the educational system just as much as the field. I'm testing right now. I'm using some of these power converters in classes here at the university, and I'm trying to explain to people that once they finish their courses, they can just go online and download the whole of the thing and use it for something else, or improve the community. It's still early because this is a long-term shot, but I think that's the strategy to go. Where it's not the person who's on the field needs something that works and that is reliable. What we need is to provide the people who are going to come with open source technology that is reliable, that they have done it for a few years, and that they know when they leave university, and then they can use, and they can, let's say, keep on the development and studying it with low-cost tools as well. That's the way I see it, and that's what we're trying to do in wind empowerment as well. I have to think about it. Yeah.
Great. Thank you, Louise. Thank you. So I'm going to try to do one quick round of questions. I might just get to a couple more speakers that we had questions for from the audience. Vijay, if you don't mind coming back on the line, and Martin as our two speakers there from the private sector. So I do have a question for you that is asking about value proposition and business. Perhaps Vijay, you want to give a first shot at it, and then perhaps Martin might want to comment on it as well. So the question
Sure.
that we have, this is coming from Huberto in our audience here. What open source technologies are viable enough to demonstrate a clear value proposition and an actionable business model that can benefit communities in both rural and urban areas? Would you like to take a stab at that question?
Sure. This is Vijay. It's a very broad question. I mean, I see if you imagine yourself as a company, there are two parts to the value proposition. There's the value that the open source brings to you as a company. So we've spoken about that. You can lower your own development costs and all that. In terms of the value proposition that you bring to a customer, it completely depends on what the product is. And so the way that I look at it is from a business-to-business perspective. So what can we offer to local businesses that they wouldn't be able to provide them for themselves? And I think it goes back to the point that Louise made earlier, which was during his presentation, which was when he said that local practitioners become resellers if they don't have the access to tools that they can customize for themselves or use their intellect on. And that's really the point that I think that's the crucial point for me. We want to avoid a situation where we are imposing technology on other countries in a top-down way, and we want to encourage a situation where local companies can innovate themselves and provide for their population.
Thank you.
Yeah.
Thank you very much.
Molly,
Martin, would you like to add to that? Oh, sure.
Yes.
sorry, after Martin, I want to get a stab at that as well. Right.
Okay.
Okay.
That was
then
Louise,
I
right?
can give my perspective as well.
Okay.
Um, yeah, I think in general, if we look at open source, and if we imagine a world with more open source products, the value to the customer could be that he doesn't necessarily need to understand everything and be an electrical engineer himself to benefit from it. But if he knows that a product is open source, he can be sure that he's not locked into a specific vendor, and he could probably go to the next repair shop who has the skills to repair his product. And this could also happen in developed countries and in developing countries. So yeah, you just need to get a community built up who is able to repair the products, and then you can have a longer lasting product and also maybe a better developed product because it was driven by the community, the development.
Thank you, Martin. So going to Dan next. We'll come back to Louise for that same question. But Dan, we have still another question from the audience, if that's okay. So,
yeah, sure.
Okay, great. So the question that we have is coming from Alberto, and his question is, how do you currently measure energy access, and how can you measure impact after implementing one of the projects?
But I know nothing about how they actually measure energy access, apart from presumably to have ideas about where populations are and where companies have installed their systems. I can't say I know a lot more about it than that, to be honest.
Okay, that's no problem.
Sorry, the second part of the question was?
The second part of the question was about measuring the impact. So let's say if you've implemented an open source idea, how do you measure then the impact that open source actually had on energy access?
Well, going back to what I was saying in my slides, I mean, MHP technology really has sort of proven itself in the sense that there are thousands of these systems that are running. I mean, people do have figures for how many MHP sites are in different countries, and there are loads of them. And all of this is possible because people have collaborated and shared their ideas and shared their designs. So I'd say that the impact is already measurably very high, generally in MHP technology. But then, in terms of measuring impact of a particular open source design, then you're sort of relying on the fact that people who do decide to adopt your design sort of get back to you and tell you about what they've done. And that's kind of the spirit of it, really, isn't it? It's collaboration and sharing experiences. So if somebody does decide to adopt your design, then if they implement it and they find that something's happened for some reason, they can tell you about it. So you'll have a measure of impact in that way. If you've got 30 people contacting you saying, "Oh, this doesn't work for this reason," then you know that at least 30 people are trying it, and then if you find a solution, then those 30 people can benefit from it. And then obviously you could have your normal metrics if you've got like an online resource where people are downloading software from it, then you can measure how many times it's been downloaded, or you can measure how many times schematics have been downloaded. So you can get another idea in that way as well. So I think that's a few different methods.
Thanks, Dan. Yeah, and I think that gets to another question that I had, but I didn't get to ask, which was the importance of community and collaboration. But I think you've answered that in part. Thank you very much. So lastly, one last question, just returning to Louise, and just to remind the audience of what the question was. So it was Huberto's question about open source technologies, and whether they're viable enough to demonstrate a clear value proposition and actionable business models that can benefit communities in rural and urban areas. Louise, would you like to comment on that?
Can you hear me?
Mm-hmm. We can hear you.
It's just that the phone, I was on the phone cut out, so I'm on my computer now, and we might have some issues. The computer might cut, I don't know if it's going to be...
It's okay. It's actually very clear right now, so...
All right, perfect. So there are two, I've answered both questions because I think there's something to add on Alberto's question and the one that was just answered by Dan just before me. Alberto, you have just an example. You have Arduino, you have Linux, you have Raspberry Pi, and you have Python. All of these are open source technologies, and you can combine them together to build any type of product that can address any type of issue. With Linux, you can get an old scrap computer, put Linux on it, it will work like a charm, and it will help you. I mean, it can help you for very low cost. You can reduce a lot of your capex. So you can refurbish old stuff with Linux. It works perfectly. You can use Linux to code on to assemble something with using an Arduino, and it's modular, so if it burns, you can replace the modules. And with Arduino, you can collect data, which you can treat with Python. And treating data with Python is basically, there's a lot of added value to that. You can treat data, you can collect data and treat data with almost no money at all, with a fraction of what would cost even 15 years ago. So there's a lot of added value in open source technology because you can combine them. You can put Linux on a Raspberry Pi to pilot a group of Arduinos which are measuring, say, a lot of things that might be interesting for you if you're trying to help people measure if they have enough sun in their rooftops to install photovoltaic, or if you're trying to measure energy use, or you're trying to measure, you want to automatize a greenhouse. All of this stuff is possible due to open source. So the added value of open source is fast prototyping, because you can have a prototype on the table within in a fraction of the time that you would require years ago. And if you have a prototype that you've tested, you kind of have an idea of how it works, you can actually go to a local bank and it's easier to get a loan if you have something on the table that's actually working. And even if you don't have a loan, this stuff is cheap, so you can actually provide services for people that you know for a lower cost, and helps you start a business. And if the people are using, which is not the case today, but if we use open source in universities, that means that you can actually get interns for free that develop stuff for you, or you can actually get engineers which have been trained in the technology and don't need to learn it again. The learning curve is can be quite fast. So the added value, and all of these is proven technology. Arduino has been in the market for years. Raspberry Pi has been in the market for a few years. Linux has been in the market for decades. And it's all of the added values that you can create. You can fast prototype, and then once you fast prototype, you can adapt to whatever need you want if you want to go to further development. And the second question about, I think it was for Dan, about how do we measure impact. The World Bank, amazingly, the World Bank has a lot of data on energy access. They publish reports regularly, so take a look at them. The United Nations published a report on microgrids in 2014, which is quite interesting report. You tap United Nations microgrid report, something like that, in Google, you're going to find it. And it gives you a very good perspective of what are the business models that work, what are the business models that don't, from 5 or 10, I don't remember, 7 different places around the world. So that's a quite good resource for you guys.
Thank you so much, Louise. That's incredibly helpful, and I hope everyone in the audience was taking notes just then. And if they weren't, we'll be happy to put you guys in touch with Louise if you want to catch some of these things that he was just talking about. So let me turn over very quickly. Lastly, just to say thank you. Let me turn over to Willington from Visions. Hi, Willington. Are you there on the line?
Hi, Molly. Yes. Do you hear me?
Yeah. I hear you well.
I want to thank all of you, the audience, first of all, for being with us and making all these interesting questions, and particularly also to our speakers. As you see, this is a very interesting topic. There are not very robust truths there. It's something that is evolving. Is my understanding, and we definitively will keep working on this topic, or with you, with the practitioners, on identifying or understanding all of these aspects that that pop up today, like the ideas of value propositions. A very interesting topic. I think there is no one answers as we heard, and also this idea of how to go in the future and how to make it broader and how to build communities. It's a very nice. Thank you to all of you for all these ideas, and I think there is enough stuff for all of us to keep thinking and talking about it.
Well, thank you, Willington. Thanks for this great idea to organize on this topic, and I hope the audience has learned a lot today. And we want to say a thank you to Vijay, Martin, Dan, and Louise for all taking the time to join us here and to share with you their experiences. So we hope you've enjoyed it. Just in case you do have a couple more minutes, we would love for you to fill in a survey that should pop up after the end of the webinar. So we would really appreciate it if you would give us a little bit of feedback on what worked for you, what didn't work for you, and what you thought of the topic. So thanks to everyone for being with us here today, and we'll look forward to speaking to you in the next Visions webinar.